Hey everyone, welcome back to the channel. I hope you are doing great. In today's video, we are going to learn how to create a simple object pooling system in Unity. By the end of this video, we will have an endless path where our player keeps moving forward, and instead of creating new land tiles every time, we will simply reuse the existing ones. Now before we start writing any code, let's first understand what object pooling actually is. Imagine you are making an endless runner game. As the player keeps moving forward, new land tiles need to appear continuously, so the player never reaches the end of the level. Now, one way to achieve this is by creating a new land tile using Instantiate. Whenever the player moves forward, and once the player passes an old tile, we can simply destroy it using destroy. This approach works, and you will even find many beginners using it. But there is one problem. Every time we call Instantiate, Unity creates completely a new game object in memory. Similarly, every time we call destroy, Unity removes that object from memory. If this keeps happening continuously, Unity spends more time creating and destroying game objects instead of running your game. As a result, your game can become less efficient, especially when you are creating hundreds or even thousands of objects. So instead of creating and destroying objects again and again, there is a much better approach. We create a fixed number of objects only once when the game starts. Then whenever we need the another object, we simply move one of the existing objects and use it again. This process is called object pooling. It is a simple idea, but it is one of the most commonly used optimization techniques in game development. You will find object pooling being used for bullets, enemies, coins, obstacles, particle effects, endless runners, and many other gameplay systems. Now that we understand the idea, let's build one ourselves. I am creating with a new 3D scene. First, we need a land type. For that, I will go to the hierarchy, right click on it, select 3D object, and create a plane. I am going to rename this plane to land. Now this plane will act as our ground. Instead of creating this plane manually every time, we are going to turn it into a prefab. So I will simply drag the land object into the project window. This creates a prefab. A prefab is basically a reusable template of a game object. Whenever we want another land tile, we simply create it using the prefab. Now that our prefab is ready, we don't need this plane inside the scene anymore. So I am going to delete it. Don't worry, even though we have deleted it from the scene, our prefab is still safely stored inside the project window. Next, let's create our player. For that, I will go to the hierarchy, right click, select 3D object and create a cube. I will rename this cube to player. Since I want to keep this tutorial focused on object pooling, I am simply using a cube as my player. If you are working on your game, you can replace this cube with your own character later. Our basic scene setup is now complete. But before we start writing the object pooling script, our player needs to move continuously. Otherwise, the player will simply stand still and we will never be able to test our pooling system. So first let's create a simple movement script. I will go to the project window, right click, select create C# script and I will name this player movement. Now I will drag the script onto my player object. Let's open the script. The first thing we need is a variable to control the player movement speed. So I am going to write this line. Serialized field private float speed is equal to 5f. This variable controls how fast our player moves. I am using serialized field because I want this variable to appear in the inspector. This allows me to change the movement speed without opening the script again. If I feel the player is moving too slowly, I can simply increase the value. Similarly, if the player is moving too fast, I can decrease it. Now let's move into the update function. Since we want our player to move continuously, we need to update its position every frame. And that's exactly what update function is used for. Inside the update function, I am going to write this line. Transform.translate vector3.forward into speed into time.delta time. Now let's understand this line carefully because every part of it has an important job. The first word is transform. Every game object in Unity has a transform component. The transform stores information like object's position, rotation, and scale. Whenever we want to move a game object, we usually work with its transform. Next comes translate. The translate function simply moves the game object. You can think of it as saying, move this object into a particular direction. Now let's look at the value we are passing inside the translate function. We are using vector3.forward. This represents the forward direction. In Unity, the forward direction is along the positive z-axis. So by using vector3.forward, we are telling Unity to move our player forward. But right now, the player would only move one unit every frame. That's where our speed variable comes in. We are multiplying the direction by speed. Now increasing the speed value makes the player move faster, while decreasing it makes the player move slower. Finally, we are multiplying everything by time.delta time. This is one of the most important things you will see in the almost every movement script. Different computers runs games at different frame rates. Some computers may run at 60 frames per second, while other may run at 144 frames per second. If we don't use time.delta time, the player would move faster on high-end computers and slow on low-end computers. By multiplying with time.delta time, Unity makes sure the player moves at the same speed regardless of the frame rate. So this one line simply tells Unity, every frame move the player forward at this speed. Now let's save the script and go back to the Unity. Press the play button. You will notice that our player starts moving continuously in the forward direction. Our movement script is now complete. So let's move the camera into child of the player. Now the camera follows the player continuously. Now it's finally time to build our object pooling system. For that I will go to the hierarchy, right click and create an empty object. I will rename it into LandSpawner. Next I will go to the project window, create another C# script and name it LandSpawner. Then I will attach the script to the LandSpawner game object. Now let's open the script. The first thing we need is the reference to our player. The reason is simple. Every frame we need to check how far our player has traveled. Once the player moves beyond the first land tile, we will move the tile into the front instead of creating a new one. So first we need access to the player position. For that I am going to write a transform variable, public transform player. At the moment this variable is empty. We will assign our player object to it later from the inspector. Next, we need a reference to our land prefab because that is the object we will create when the game starts. So I am going to write this line. Public game object land prefab. This variable stores the prefab that we are going to use for creating our land tiles. Notice that we are only using this prefab during the initial setup. After that, we won't keep creating new land tiles again and again. Instead, we will keep reusing the same ones. Now that we have created references for our player and our land prefab, let's continue with the remaining variables. The next thing we need is a variable that tells Unity how many land tiles should exist in our scene. So I am going to write this line. Public int tiles count equal to 10. This variable determines the total number of land tiles we will create when the game starts. I have set the value to 10, which means Unity will create only 10 land tiles. Now you might be wondering, why only 10? Imagine your player keeps running for 5 minutes. Do you really need to create thousands of land tiles? The answer is no. At any moment, the player can only see a few land tiles. So instead of creating hundreds or thousands of game objects, we will create just 10 tiles. Later, when the player moves forward, we will simply reuse those same 10 tiles again and again. This is one of the biggest advantages of object pooling. Now let's create another variable. Public float span distance is equal to 1f. This variable tells us when it is time to reuse a land tile. Instead of waiting until the player is exactly at the end of the tile, we will trigger the recycling process just a little earlier. That's why I have kept this value as 1. You can increase or decrease this value depending on your game. Now let's create another variable. Public float tile length equal to 10f. This variable stores the length of a single land tile. I am using 10 because my plane has a length of 10 units. If your land tile has a different size, simply change this value to match your tile. This value is very important because we will use it to calculate when the next tile should be placed. Now we need a place to store every tile that we create. For that we are going to use a list. So I am going to write this line. Private list game object tiles equal to new list game object. Let's understand why we are using a list. When we create our land tiles, Unity creates multiple game objects. If we don't store them anywhere, we will have no way to access them later. A list allows us to store multiple game objects inside a single variable. You can think of it like a collection. Every time we create a new land tile, we will simply add it to this list. Later, whenever we want to reuse a tile, we can easily access it from the list. Finally, let's create one more variable. Private float next one z. This variable stores the z position where the next land tile should be placed. Every time we recycle a tile, we will update this value so the following tile appears at the correct position. Now that all our variables are ready, let's move into the start function. Remember, we only want to create our land tile once. After that, we will simply keep using them. So inside the start function, I am going to write a for loop. For int I equal to 0, I less than tiles count I plus plus. Let's understand this loop. The variable I starts from 0. Every time the loop runs, I increase by 1. The loop continues until I becomes equal to tiles count. Since our tiles count is 10, this loop will run 10 times. Now inside the loop, let's create our land tile. Game object tile equal to instantiate land prefab new vector 3 0, 0, I into tile length quaternion dot identity. This line may look a little big, but it is actually very simple. First we are using instantiate. Instantiate creates a copy of our prefab. Since we are using land prefab, Unity creates a copy of our land tile. Next, let us look at the position. New vector 3 0, 0, I into tile length. We are keeping the x position at 0. We are keeping the y position at 0. The interesting part is the z position. Instead of writing a fixed value, we are writing I into tail length. Let's see how this works. During the first iteration, I equal to 0. The position becomes 0 into 10 equal to 0. So the first tail is placed at z equal to 0. During the second iteration, I equal to 1. 1 into 10 equal to 10. Now the second tail is placed at z equal to 10. Next I equal to 2. 2 into 10 equal to 20. So the third tail appears at z equal to 20. Then 30, 40, 50, 60 and so on. As you can see, every tail is placed exactly after the previous one. This creates one long continuous path for our player. The last parameter is quaternion dot identity. This simply means we don't want to rotate our prefab. Unity creates every land tail with its original rotation. Now we have successfully created one land tail. But that is not enough. Remember, later we need to reuse these tails. So we need to store every tail inside our list. For that I am writing this line. Tails.add tail. The add function simply stores the game object inside our list. Every time the loop creates a new tail, the tail is immediately added to the list. By the time the loop finishes, our list contains all 10 land tails. Now that we have created every tail, we need to calculate where the next tail should appear. For that, outside the loop I am writing this line. Next span z equal to tail count into tail length. Let's understand why we are doing this. We are creating 10 tails. Each tail has a length of 10 units. That means our tails currently occupy these positions 0, 10, 20, 30 and so on. The next empty position is 100. So we store this value inside the next span z. Later whenever we recycle a tail, we will move it to this position. After that we will update this value again. At this point if you press play, you will see all 10 land tails placed one after another. We have successfully created our initial pool of land tails. Now the only thing left is to detect when the player passes the first tail and move the tail to the front. That is exactly what we will build in the next part using the update function and our reuse tail method. Now that we have created all our land tails and stored them inside a list, the next step is continuously check whether the player has passed the first tail. If the player hasn't passed it yet, we will simply do nothing. But as soon as the player moves beyond the tail, we will move it to the front instead of creating a new one. Further, let's move into the update function. Remember, the update function runs once every frame. Since our player is moving continuously, we need to check the player's position every frame as well. The first thing we need is the oldest land tail. So I am going to write this line. GameObject oldest tail equal to tails of 0. Let's understand what this line does. Earlier, whenever we created a land tail, we stored it inside our list using the add function. This means our list looks something like this. Tail 1, tail 2, tail 3, tail 4, tail 5 and so on. The important thing to remember is that the first tail we created it stored at index 0. That also makes the oldest tail because the player will reach it first. So whenever we write tails of 0, we are always getting the oldest tail in our scene. Now that we have the oldest tail, we need to check whether the player has completely crossed it or not. For that I am going to write this line. If player.position z plus span distance greater than oldest tail transform position plus tail length, then reuse tail. At first glance, this condition might look a little confusing. So let's break it down into smaller parts. Let's start with this set, player.position.z. This simply gives us the player's current position on the z-axis. As our player keeps moving forward, this value keeps increasing. Now let's look at the second part, plus span distance. Instead of waiting until the player reaches the exact end of the tail, we are adding a small offset. This gives us a little flexibility and helps us decide exactly when we want to recycle the tail. Now let's look at the other side of the condition. Oldest tail.transform.position.z. This gives us the starting position of the oldest land tail, but we don't want the starting of the tail. We want the end of the tail. So we simply add this tail length. Oldest tail.transform.position.z plus tail length. Now we have the position where the tail ends. Finally, let's understand the complete condition. We are basically asking Unity one simple question. Has the player moved beyond the end of the oldest tail? If the answer is no, nothing happens. If the answer is yes, that tail is no longer useful behind the player. Instead of destroying it, we will simply moving it to the front. That's why we are calling the reuse tail function. So now let's create that function. Void reuse tail. Inside the function, the first thing we need is the oldest tail. So once again I am writing this line. GameObject oldest tail equal to tails of 0. This gives us the exact tail that needs to be recycled. Now instead of creating a brand new tail, we are simply going to move this existing tail. For that I am writing this line. Oldest tail.transform.position equal to new vector 3 of 0, 0, next span set. This is the most important line in the entire tutorial. Notice what we are not doing. We are not calling Instantiate. We are not creating a new game object. We are simply changing the position of an existing tail. We are taking the oldest tile from behind the player and placing it at the very end of the path. This is the core idea behind object pooling. Instead of creating new objects, we reuse the ones we already have. Now we have moved the tile, but there is still one problem. Our list still thinks this tile is the oldest one, but that is no longer true. We have moved it to the very end of the path. That means it has now become the newest tile. So we need to update our list as well. First, let's remove the tile from the beginning of the list. Tiles.removeAt 0. The removeAt function removes an element at the specific index. Since we are passing 0, Unity removes the first tile from our list. Now our list look like this: tile 2, tile 3, tile 4, tile 5 and so on. But remember, we haven't destroyed the tile. We have only removed its reference from the list. The game object still exists in our scene. Now let's add that same tile back to the end of the list. Tiles.add oldest tile. Now our list becomes something like this: tile 2, tile 3, tile 4, tile 5 and so on, tile 1. Now notice what happened. The tile that was previously the oldest has become the newest. This keeps the order of our list correct. Finally, we need to update the position where the next tile should appear. For that, I am writing this line: next spawn z plus equal to tile length. Let's understand this. Suppose our current next spawn z value is 100. We moved the recycle tile to 100. Now the next empty position is no longer 100. It is 110. So we simply add one tile length. The next time we recycle another tile, it will automatically move to the correct position. And that's it. Our object pooling system is now complete. Let's save the script and go back to the Unity. Before entering the play mode, make sure you have assigned both the player and the land prefab in the inspector. Also make sure the tile length matches the actual length of your land tile. For example, if you are using Unity's default plane with a scale of 1, the tile length should be 10 because a Unity plane is 10 units wide. If you are using a different object or you have changed its scale, simply set the tile length to match its actual size. Now let's press the play button. As the player starts moving forward, you will see something interesting. Initially, Unity creates only the number of tiles we specified. After that, no new tiles are created. Instead, whenever the player passes the first tile, that same tile is moved to the front. This process keeps repeating forever. If you look at the hierarchy while the game is running, you will notice that the number of game objects never increases. That is because we are not creating new objects anymore. We are simply reusing the ones that already exist. And that is exactly what object pooling is. It is simple but powerful optimization technique that you will use in many different types of games. Whether you are making an endless runner, a shooting game with bullets, an enemy wave system, collectible coins, or particle effects, object pooling helps improve performance by reducing unnecessary object creation and destruction. I hope this tutorial helped you understand not just how to implement object pooling, but also why it is used. If you found this video helpful, consider liking the video and subscribe to the channel for more Unity tutorials. Thanks for watching, and I will see you in the next video.